In problem number 3, we have 4 pipes, and they're each 2 feet in diameter, and they're held together tightly by a metal band, as shown in this diagram here. And the question asks, how long is the metal band? And we can express our answer in terms of pi. So since I told you that you shouldn't use the calculator for this question, you don't have to do the multiplication and figure out the exact answer. You can put it, well, actually pi is, expressing it in terms of pi gives you the exact answer, but you don't have to calculate it out. So let's take a look at this. All right, so we know that the pipes are 2 feet in diameter. Okay, we're going to assume that's outer diameter. All right, so we don't really know how thick the walls are of these pipes. We're going to assume the outer diameter is 2. So that means that the radius is 1, right? Because the radius is just half the diameter. The diameter would be all the way across the pipe, and the radius is the measurement from the center out to the outer edge. Okay, so the radius is 1, and so we get this band out here. Let me highlight it for you. So we have this band. Oh, I'm gonna actually just pick up another color. Alright, let me see if I can draw this band. So we have this band out here, and it curves around. I can draw it, and comes down, and it curves around again. Alright, and comes across. Ooh. And then up. Ooh, man, I'm not doing very well here with my straight drawing, but you get the idea. Okay, we got this band that's holding the pipes together, and we have a radius of 1. Oops. And so let's figure out what we know. We could draw in some more radiuses here. I'm going to draw in some more radiuses. And I'm doing this because you can see that as this band comes around and curves around the pipe, at some point it quits touching the pipe and it's just sort of out in space here. And then it touches the pipe again, and then it curves around, and then it bridges over here to this next pipe, and then I'm drawing another radius here, and then curves around, and again, it quits touching the pipe, bridges over to this next one, and so on. Okay, so let me just draw it. Let's show where the band quits touching the pipe. Okay, oops, I'm trying to draw in the radiuses here. Okay, because we need to break the band into some segments. And so let's take a look at the curved segments first. So we have 4 curved segments. So it's curving around this pipe for a certain distance, and it's curving around this pipe, and this pipe, and this pipe. But if you look at the amount that it's curving, it's like a quarter of a circle. It's completing quarter of a circle here, and then it goes straight, and then it completes a quarter of a circle, and then goes straight, and another quarter of a circle, and goes straight, and then another quarter of a circle. So if you look at just the curved portions of the band, you actually complete a whole circle, which makes sense because in order to come back to where you started, you have to go a full 360 degrees. So even though we curve and then we go straight, and we curve and go straight, the amount of the curved portions will bring you around a full 360 degrees. So, given the curved portions, so the curved portions of the band will just be the circumference of a circle. Okay, and we know that the circumference of a circle is just pi times the, let me see, 2 pi r, or pi times the diameter. Okay, same thing. So in this case, the curved portions, the length of the curved portions is just going to be 2 pi, right? Because our diameter is 2. and we've got to complete a full circle. So it's curving around this pipe in 4 curved segments. All right. So that's the curved portion of the band. Now let's look at the straight portions of the band. We've got a straight portion here, 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 and here. Okay. And so again, let me draw in the diameter here. So I know that the distance here is 1, and I also know that the distance here is 1. So, and I know that this is 90 degrees, so you can see that essentially this straight segment here is just going to be equal to 2 radiuses. All right, so it's just 2. And the same thing over here. I can draw a radius here, and I can draw a radius here. They're each going to be 1, so the distance of this straight segment is 2. And it'll be 2 over here, and it'll be 2 over here, down here, I should say. Didn't draw that very well. Okay, 2. So 2 plus 2 plus 2 plus 2, that gives you 8. So the straight portions are going to be 4 times 2, which is 8. All right? So the length of the band, the total length of the band, will just be the sum of all these portions. All right? So we have 2 pi for the curved portions, and then we have 8 for the straight portions. All right? And there's our answer. So you could multiply that out if you wanted to. 3.14 times 2 would give you 6.28, and then add that, so that's 14.28, right? Approximately. So the approximate answer is 14.28. And you should probably put the units on this too. So this is feet, right? Because the units here were feet, so we're figuring out everything in feet. So it's important to put the units with this. Okay. So there you go.